I'm Jo Bellamini, and this is my Honors Physics 253 lab project, where I studied projectile motion. For this project, I analyzed how the initial angle of a projectile affected the range. I performed this experiment by using a ballistic pendulum. By using the ballistic pendulum, I angled it at different heights by using different sized wooden blocks. And by doing this, I manipulated the initial angle that the projectile or ball was launched at. I also moved the pendulum out of the way so that the ball was free to move in a parabolic path. Once I prepared the ballistic pendulum, I put a piece of carbon paper on the ground in order to mark where the ball or projectile landed. This allowed me to analyze the range of the projectile. As well as measuring the range of the projectile, I also analyzed the initial velocity of the projectile. I did this using a photogate and Logger Pro. By analyzing when the ball went through the photogate, I was able to determine the time it took for the ball to go through the photogate. And I was able to calculate the initial velocity by dividing the diameter of the ball by the change in time. I calculated the change in time by using Logger Pro. Logger Pro showed on the computer when the ball first went through the photogate and when it last went through the photogate. And I found the change in time by finding the difference between these two values. And this gave me the time it took for the ball to travel through the photogate. The upcoming video shows the ball traveling through the photogate as it was launched by the spring gun. The next videos show me pulling the trigger for the spring gun to launch the projectile for the 3 sets of my experiment. Set 1 using the smallest initial angle, set 2 using the angle between the largest and smallest angle, and set 3 using the largest angle in my experiment. And this showed how the initial angle changes the range of a projectile. So this is trial 1 for angle 1, where I'll be shooting a projectile. This is trial 2 for angle number 2. And this is trial 3 for angle number 3. The following are my notes for the experiment showing my data and results. I first measured the initial angle of my projectile, and I did this using similar triangles. I measured a bottom length of the ballistic pendulum and then measured 2 different heights to find my initial angle. For the first set of my experiment, I measured the bottom length to be 0.25 meters and the 2 heights to be 0.035 meters and 0.051 meters. The difference between these 2 heights was found to be 0.016 meters, and then I used the tan inverse function to find my angle, which was 3.7 degrees. Once I measured the initial angle, I was able to record the change in time it took for the ball to travel through the photogate, and I found the average change in time to be 0.005 seconds. To find the initial velocity, I took the diameter of the ball and divided by the change in time. To find the diameter of the ball, I measured around the ball to find its circumference and then used basic algebra to find the radius. Once I found the radius, I multiplied it by 2 to find the diameter of the ball to be 0.025 meters. Then my initial velocity became 0.025 meters divided by 0.005 seconds to have an initial velocity of 5.0 meters per second. Once I found the initial angle and the initial velocity of the projectile, I measured the range of the projectile. I first did this by measuring the distance from the initial point of projectile motion to the edge of the carbon paper I placed on the ground. I did this using a meter stick and found the distance for set 1 to be 2.087 meters. From there, I measured the distance from the edge of the carbon paper to the marks the ball made when it hit the carbon paper. And then I found the average of these distances and found for set 1 this to be 0.1358 meters. From there, I added the distance from the initial point of projectile motion to the edge of the carbon paper to the average distances of the marks on the carbon paper and found the range for the projectile for set 1 to be 2.214 meters. For set 2, I used the same methods to find my results. For the initial angle, I measured the bottom of the ballistic pendulum to be 0.25 meters and my 2 heights to be 0.054 meters and 0.101 meters. The difference of these 2 heights then was found to be 0.047 meters. I then again used the tan inverse function to find my initial angle to be 10.6 degrees. I then found the average time it took for the projectile to travel through the photogate to be 0.005 seconds, the same as set 1. And since the diameter of the projectile did not change between set 1 and set 2, the initial velocity was found to be 5.0 meters per second, the same as set 1. I then found the range for set 2 using the same methods as set 1 and found it to be 2.587 meters for set 2, which was larger than set 1. For set 3, I found the initial angle and the initial velocity using the same methods as set 1 and set 2, and found the initial angle to be 21.8 degrees. I then found the initial velocity to be 5.0 meters per second, which was the same as set 1 and set 2. I then found the range for the projectile for set 3 using the same methods as set 1 and set 2, and found it to be 3.014 meters, larger than both set 1 and set 2. The following are the same notes on a whiteboard so that they can be seen more clearly. This is for set 1. This is for set 2. And this is for set 3. In conclusion, in this experiment, as the initial angle increased from 3.7 degrees to 21.8 degrees, the range of the projectile increased. Now, it is known that as the initial angle of a projectile increases to 45 degrees, the range of the projectile increases, and the maximum range is found at the initial angle of 45 degrees. And actually, as the angle increases above 45 degrees, the range of the projectile decreases. Since in my experiment, the angle only increased to 21.8 degrees, the range of my projectile only increased. And this supports the idea that as the initial angle of a projectile increases to 45 degrees, the range of the projectile increases.